Okay, today we're going to look at Lesson 2, and our I can statement or learning objective is I can factor quadratic expressions. So we're still factoring, we're just doing a different kind of factoring, and this is part 1. We'll do part 1 in Lesson 2, and then Lesson 3 will have part 2 in it. And I realized that was kind of confusing as how I said that, but either way, we're factoring quadratic expressions. So I do expect you to write these notes down, try the examples, and follow along with me. Now, we are going to look at a few different ways to factor in this lesson. Okay, so it's going to be a little bit different. If we were in person, this lesson would be a lot easier. But just know going in that I'm going to show you some different methods. You're going to need to pick one and go with it. So you can do examples differently than what I do here in the notes. Okay, so just keep that in mind. Also, remember, I'm going to go faster in the video than I would in person. So feel free to pause, rewind, do whatever you need to do as we go along. Okay. So first, we need to talk about what a quadratic expression is. A quadratic expression is an expression in the form ax squared plus bx plus c, where a, b, and c are constants, or numbers, and a cannot equal 0. A cannot be 0 because if a was 0, this term would go away and it would no longer be quadratic. Quadratic means that the highest exponent is 2. So the highest exponent you're going to see in your expressions today is 2. Okay, that means they're quadratic. Just a reminder, expressions do not have equal signs. Okay, expressions do not have equal signs and you can't solve them. We are not solving for anything. We are factoring. Okay, factoring. Remember, you break a quantity apart into 2 factors or multiple factors. So we can break 10 up into 2 times 5. We can break x squared plus 5x plus 6 into x plus 3 times x plus 2. This is what we're doing. Remember, when you factor, you're breaking the expression up into as many smaller parts as possible. Now, before we start factoring, I'm going to give you a little tip for your signs. So when you have a quadratic expression where your b term is positive and your c term is positive, that means that both of your factors are going to be positive, because if you multiply 2 positives, you get a positive, and if you add 2 positives, you get a positive. If you have a negative b term and a positive c term, that means that both of your factors are going to be negative, okay, because a negative times a negative makes a positive, but if you add 2 negatives, you still get a negative, okay? If you have a negative b term and a negative c term, or a positive b term and a negative c term, which really you just notice here, it doesn't matter what b is, as long as you have a negative c term, then you're going to have one of each. You're going to have a positive factor and a negative factor, because if you multiply a positive times a negative, you get a negative. And then when you add those together, it depends. You could get a negative or you could get a positive. Now, this is not some hard, fast rule that you need to base everything you do off of, okay? This is just some help. If you get stuck on the signs and you aren't sure, or you just need an extra little tip, you can come back here and it can help you, okay? Especially if you don't have a common factor, your coefficient in front is 1, okay? These can be super, super helpful. Now, we're going to start looking at the 3 different ways to factor quadratic expressions. But first, you always have to check for a GCF. So it doesn't matter if it says factor out the GCF, or if it says factor by grouping, or if you're just given a quadratic expression and asked to factor it. The very first thing you need to do is check for a GCF. See if there's a common factor among all the terms that you can pull out. If you don't do that, you will not be able to factor it all the way. Okay, the first method we're going to look at is the guess and check method. So for the guess and check method, you find factors of A and factors of C, and then you just try some different combinations until you find one that works. So I'm going to work out this example, 3x squared plus 8x plus 5. I'm going to work out the same, or factor the same quadratic expression each way, so you can see how they all lead to the same answer. It's just a different way to get there, okay? Now, guess and check can be the easiest and quickest method when your quadratic expression has small numbers, okay? Especially if A and C are prime numbers. Guess and check is usually the quickest. But for those of you who like a challenge and like a puzzle, then you might like using the guess and check method when problems are a little bit more difficult. But just know that sometimes guess and check will take more time. So you'll notice I'm transitioning to a pencil here because with the guess and check method, a lot of times you have to do a lot of erasing and trying again. So I recommend using a pencil for guess and check. So if this is my expression, I know that this is A, this is B, and this is C. So I need factors of A, so 3. This one's pretty easy. The only factors of 3 are 1 and 3. Okay? Now, our coefficient is positive, so we don't worry about negatives here. Okay? We also need factors of C, which is 5. So my factors of 5 can be 1 and 5. It can also be -1 and -5 because both pairs multiply and give us +5. However, if you look at your sign help that we wrote down, if you have B and C both positive, which we do here, then both of your factors are going to be positive. So I can eliminate this. So that narrows down my options. So we're going to make 2 binomials. All right, we're going to use the factors of A in the front, so that's 1x and 3x, okay, because 1 times 3 is 3, x times x is x squared. Now, over here on the side, we need 1 and 5, so we just have to decide where those are going to go. I'm going to put a 5 here and a 1 there, and we said they're both positive. Okay, so I need to check. So x times 3x is 3x squared, x times 1 is x, 5 times 3x is 15x, and 5 times 1 is 5. So if I combine those middle terms, I get 16x. Is that what I wanted here? No. So that doesn't work. So I'm going to have to change these terms so I can swap them. What about if I put 1 and a 5? Let's try that one. So x times 3x is still 3x squared. X times 5 is 5x. 1 times 3x is 3x, and we know 1 times 5 is still 5. If I combine my middle terms now, I get 8x. Is that what I wanted? Yes. So this is my final answer. We have the quantity x plus 1 times the quantity 3x plus 5. And that's how guess and check works. Okay, our next method is to factor by grouping. We did some factoring by grouping back in lesson 1. And at the end of those notes, we talked about how you can use factoring by grouping on a trinomial, okay, on a quadratic expression. So you just have to do a little bit of work first. You've got to turn it into 4 terms instead of 3, and then you can go from there. So you can use an X to keep things organized. And we need to find factors of AC that add up to equal B. So we know this is A and this is C. So 3 times 5 is 15. Okay, and we put B in the bottom. So B is 8. So we need factors of 15 that add to equal 8. Now, in this case, this one is actually pretty easy because it's what we're given here. But some factors of 15 are 1 and 15, 3 and 5. And then you could do the negatives of each of those. But we know we're adding to get to a positive 8, so our options are 3 and 5. So I put a 3 on one side, 5 on the other. And I'm going to use those to split up my middle term. And that's what I do next. So I'm going to change this to 3x squared plus 3x plus 5x plus 5. Now I can factor by grouping. So I split it in half, and I find my greatest common factor of this side, which is 3x, and I'm left with x plus 1. On this side, my GCF is a positive 5, and I'm left with x plus 1. Now I can see that my GCF is x plus 1, and my leftovers are 3x plus 5. And that's my final answer. And that should be familiar because that's what we got using guess and check as well. You can check your answers. X times 3x is 3x squared. X times 5 is 5x. 1 times 3x is 3x. And 1 times 5 is 5. And if you combine your middle terms, that is what we started with. Okay, so you can use factor by grouping. This is a great way if guess and check is taking you a long time, you're having trouble with it, or your numbers are just way larger than what they should be. Use factor by grouping. If you like that, if you liked factoring by grouping, it seems easy for you, you can use this method every single time and it's still going to work. Okay, the last method we're going to look at is what I call the star method. Different teachers call it different things, but I just call it the star because it looks kind of like a star, like an asterisk. But you can call it whatever you want to as long as you know how to use it. So to use this method, you find the factors of AC that add up to equal B. Okay, so you use this star where AC is on the top, B is on the bottom. You have AX on each top side, and then you're going to put the factors in the bottom sides. So after you find out the factors of AC that add to equal B, you put those factors in here. You simplify the side fraction. So you treat this just like a fraction, and you simplify it. Some notes, if there's a 1 on the top or bottom, you leave it alone. And negatives always stay on the bottom with that bottom factor. Okay? After you do that, you make your two factors or your two binomials, and then you can check your answers and you're good to go. So just like with the other methods, we're going to use this same polynomial. I'm going to show you how this works. And this is a great method if you've tried guess and check, and you're just coming up short, you can't figure it out, it's taking forever, or your numbers are large and you just can't get it figured out, and you don't really like the factor by grouping method, you can use the star method every single time and it'll work. Okay, it's like a fail-safe. If you do the star correctly, it will take you to the correct factors every single time. Okay, so we've labeled A, B, and C, and we're going to use our star. So let me make that real quick. So AC is 15, B is 8, AX is 3X. Okay, so now I need factors of 15 that add to equal 8. So again, I know we listed these before, but I'm just going to list them out just so you can see. So I pick the pair that adds to equal 8. I put a 3 here and a 5 there. So here I have 3x over 3. 3 over 3 simplifies to 1 over 1. 3 over 5 does not simplify. If you're unsure, you can type 3 over 5 in your calculator and see what happens. Okay. So we have x and positive 1, 3x and positive 5. I'm going to make my two factors or my two binomials. So x plus 1 and 3x plus 5. And that is my final answer. We know that's the answer because we've gotten it 2 times before. But again, check your answers. X times 3x is 3x squared. X times 5 is 5x. 1 times 3x is 3x. And 1 times 5 is 5. If you combine your middle terms, that is going to give you what we started with. Okay, so like I said earlier, you have 3 different methods. You can pick one and stick with it. You can mix it up and do guess and check when that seems easier, grouping when that seems easier, or you can do the star method. It really does not matter to me. And as we work through some examples, you're going to see me use each one just so you can practice that. But I need you to take a little ownership over your notes here, pick a method, try it, see if you can get to the same answer as me, and go from there. And if you need specific help on any of these methods, or you need me to go over something again, I would be happy to. You just have to let me know. Okay, now we're going to work through some examples. So what I would like to do is I'll do this example, and I'll show you how to do it all 3 ways. And then on the next example that's going to be very similar, I want you to try it on your own and then pick a method, okay? So for this one, first we need to check for a greatest common factor. So we have 15, 25, and 10. I can pull out 5. Each term doesn't have a b, so I can't pull that out. So I'm going to have 3b squared minus 5b minus 2. And so this is the quadratic expression that I need to factor. So I can do it a couple different ways. So I can guess and check, do it by grouping, or the star method. Okay, so 3 and 2, those are both pretty small, so I can do, so guess and check probably won't be too bad. So I need the factors of 3, which are 1 and 3, and negative 2, so it's negative 1 or negative 2. Okay, so I'm going to bring down my 5, my GCF, and then I'm going to make my 2 sets of parentheses for the factors. I know I need a 1b and a 3b. Right, those are my only options there. And then I have negative 2 and, and I just realized that I miswrote that. So negative 1 and positive 2, or negative 2 and positive 1. So those are our 2 options there. So just pick a pair, plug them in, and see if it works. So I'm going to do negative 1, positive 2. I'm going to do that way. And then I can check. So negative 1 times 3b is negative 3b. B times 2 is 2b. And that gives me negative 1b. That's not what I want there, so that one's not going to work. All right, so if I just change the signs, that's not going to work either. It'll just change the sign of what I had in the middle. So what about if I try this? If I do positive 2, negative 1. So 2 times 3b is 6b, and then b times negative 1 is negative b. 6 minus 1 is 5b. Okay, that's super close to what I should have in the middle, but I need a negative. So I can fix that by changing my sign. So I can change it to a negative 2 and a positive 1. So that would give me negative 6b plus b is negative 5b, and that works. Okay, so that is my final answer. I could also do it by grouping if I wanted. So you can make that x, and you could do 3 times negative 2 is negative 6, and put negative 5 in the middle. 2 numbers that will add to give me negative 5, and will multiply to give me negative 6. So that's a negative 6 and a positive 1. And so I can rewrite this as 3b squared minus 6b plus b minus 2. And I can split it in half. My GCF here is 3, so I would have, or 3b, sorry, so I'd have b minus 2. And over here I notice that this is also b minus 2, so I'm going to pull out a positive 1. So I have b minus 2. And I would have b minus 2 as my GCF, and then the leftovers are 3b plus 1. Okay, and again, that gives me those same 2 factors. All right, or you could do the star method and do 3 times negative 2 is negative 6. Put negative 5 in the middle, 3b on each side, and we would have negative 6 and 1. 3 over negative 6 changes to 1 over negative 2. And that there's already a 1 there, so we leave it. And so that would give us b minus 2 and 3b plus 1. Okay, so we get those same 2 factors either way. The only thing, if you're going to do one of these methods, make sure you don't forget to put that 5 in front. So you got to put that GCF back in front to get your final answer. Okay, here's our next example. And after I wrote it down and then I looked at it, and this is actually not a great example. I didn't mean for us to do it this early, but that's okay. It'll work out the same way. So take just a second, give it a try, see what you can figure out. Okay, so first we need to look to see if we have a GCF. So 3, 21, and 15. I can pull out a GCF of 3. And so I will have x squared minus 7x minus 5. Okay. Now, this one's pretty easy. You could do guess and check. You could do the star. You could do factor by grouping. Lots of different options there. Okay, so I think I'll use the factor by grouping. Okay, so I'll make an x. And so I need a times c. So 1 times negative 5 is negative 5. And then I have negative 7 in the bottom. So I need 2 numbers that multiply to give me negative 7 and add to give me negative 5. Or I think I just said that backwards. I apologize. two factors of negative 5 that had to give me negative 7. So the factors of negative 5 are negative 1 and 5, or positive 1 and negative 5. Those are the only options. So do either of those add up to give me negative 7? No. So that means that you cannot break this down any farther. The only thing that we could do was pull out the GCF. This expression in parentheses all by itself is not factorable. So we have to stop here. Okay, and I think you do have one or two like that in Math Excel, so it's good that we looked at it. I didn't mean for us to look at it this early in the examples. Okay, here's example number 3. This one's pretty easy. I'm going to ask you to pause the video, give it a try, and then come back and check your answer. Okay, so we don't have a GCF, so we're going to go ahead and make our two binomials. All right, you can use guess and check, the star method, or factor by grouping. I think I'm going to use guess and check here just because I think it's going to be pretty easy. So we need factors of A, and so A is just 1. So we don't have to worry about that because we're just going to have W and W. Now we need factors of 72 that add to give us 17. So I can do 1 and 72. I can do 2 and 36. I can do 3 and, let me see, I don't know that one right off the top of my head. 24, and I could keep going and keep going. But one that jumps out at me real quick is 9 and 8. Well, 9 plus 8 is 17, so that's just going to be W plus 9 and W plus 8. And you can check that, 9W, 8W, that is 17W, so that is our correct answer. But remember, you could do it a different method and still get the same thing. Okay, number 4 is very, very similar. Give it a try and see what you get. All right, on this one, I'm going to do the star method. I don't have a GCF. A times C is just 24. 10 is on the bottom. We have X on both sides. Okay, sorry about that. Had a couple things going on in here. So I put AX, or just 1X, on both sides. I need factors of 24 that add up to give me 10. So I can do 1 and 24, 2 and 12, 3 and 8, 6 and 4. 6 and 4 are my winners. There's nothing to simplify, so my two factors are just X plus 6 and X plus 4. And again, you can do repeated distribution to check your answer, or X times X is X squared, 6 times 4 is 24, 6X plus 4X is 10X. Okay, here's example number 6. Write it down, pick one of the methods and give it a try, see what you can do. Okay, let's check our answer. So for this one, I'm going to use factor by grouping. So I'm going to use my X. I don't have a GCF, so I can skip straight to this. 6 times 2 is 12. I have negative 7 on the bottom, so I need two numbers that multiply to give me 12 and add to give me negative 7. So for 12, I could have 1 and 12, 2 and 6, 3 and 4. And then we can also have the negatives of those. All right, so the pair that's going to add to give me negative 7 is negative 3 and negative 4. So 6C squared minus 3C minus 4C plus 2. Okay, split it in half. We can factor out the GCF. So we have 3C. So we're left with 2C minus 1. And pull out a negative 2. And we're left with 2C minus 1. Now you notice our GCF is now 2C minus 1, and our leftovers are 3C minus 2. And so that is our final answer. And I just realized I should have done all this in orange because that was our work. But you guys get the idea. Oh, there you go. You guys get the idea. Okay, and here's our last example. We have negative 10W minus 129W minus 50. So I wanted to do a problem that had some bigger numbers and a GCF. So first, let's look for our GCF. 10, 129, and 50, there's not really anything other than 1, but our leading coefficient is negative, so that means we need to pull out a negative, which will change this to 10w squared plus 129w plus 50. Now, these are larger numbers. 10 has a lot of factors and 50 has a lot of factors, so I probably wouldn't do guess and check here. But what I might do the star method. So A times C is 500, and our B is 129, and we have 10W on each side. So we need factors of 500 that give us 129. So we can go about this strategically. So if you think we have 1 in 500, well, there's no way that's going to give us a 129. We can do 2 and 250. Again, there's no way that's going to give me 129. 500 is not divisible by 3, so that's not going to work. What about 4? What is 500? What is 500 divided by 4? And you get 125. So 125 and 4. Okay, can that give us a 129? Yeah. So 129 and 4. All right, so, or 125, sorry, 125 and 4. So we simplify the fraction. So if you do 10 over 125, that simplifies to 2 over 25. Okay, and if you simplify 10 over 4, you get 5 over 2. So that leaves us with, remember, you got to leave the negative up front, your GCF. We have 2W plus 25. And 5W plus 2. And you can check your answer. So 2W times 5W is 10W squared. 2W times 2 is 4W. 25 times 5W is 125W. 25 times 2 is 50. And if you put a negative, that would all work out. So this is your final answer. Okay. Now, we've gone through a few different examples, but remember, you do not have to work them out the same way I did. Pick one of the methods that works best for you and go with it. Okay? Remember, the higher numbers, it might be easier to do factor by grouping or the star method. If you have smaller numbers, especially prime numbers, then guess and check might be easier for you. It really just depends on your preference. So as usual, if you are stuck or you need help, you need to see more examples or want me to walk through some of the methods with you, just let me know, hop back in the Google Meet, and I would be happy to assist you. Have a great rest of the day.